For the hypothetical reaction, A plus B goes to C, based on the following data, what is the rate law? Okay, so we're going to give you some data here, and they give you some data, experiment, and then we have the concentration of A, we have the concentration of B, and then we have the rate. So experiment 1, 2, 3, 0.20, 0.20, 0.40, 0.10, 0.20, 0.10, and we have 2.5 times 10 to the negative 2. We have 5.0 times 10 to the negative 2, and we have 5.0 times 10 to the negative 2. And our choices are the following. K times the concentration of A, K times the concentration of A squared, C is K times the concentration of B, D is K times the concentration of B squared, and E, K times the concentration of A times the concentration of B. Okay, so now let's take a look at this data. Whenever we compare two experiments, when we're given concentration data and rate information, whenever we compare two experiments, we need to find something where only one of the concentrations changes. Because again, we're only dealing with one independent variable for anything that we compare. So in this case, when we change B from 0.1 to 0.2, when we double it, we ended up doubling the rate. Okay, so that means that it's going to be first order in B. So the rate is K. So far we know that it's first order in B. Because again, when you double something and you double the rate, that's first order in that reactant. Well, now let's take a look at experiment 1 and experiment 3. So let me do this in red. Now we look at 1 and we look at 3. Here the B concentration stays the same, but we double up A and A. So let me see here. 0.2, 0.4, 0.2, oh wait, I'm sorry, our data is wrong. It's not 0.1, this is 0.2. That's 0.20. Okay, let's try this again, shall we? Let me erase this and let me put in blue again. This is 0.10, 0.20. This is 0.20. Okay. Yeah, I think that's going to change some things. Okay, so now let's take a look at experiment 1 and 2 again. That's fine. So 0.2, 0.2, that's the same. We double up the concentration of B, and then we end up doubling the rate. So yes, not a problem. Our rate is, that part is the same. It is going to be first order in B. And now let's see. Now let's look at experiment 2 and experiment 3. 0.2, 0.2, B is the same. When I end up going from changing the concentration of A from 0.2 to 0.4, when I double that, the rate goes from 5.0 times 10 to the negative 2, 5.0 times 10 to the negative 2. I doubled the concentration, but the rate didn't change. Therefore, the rate is not dependent on A at all. So we're done. Rate is KB. Our choice is C. That's it. Anytime you have data like this, you take a look at some doubling, some change in concentration, and you see how the rate changes. And that'll tell you the order of that particular concentration term in the differential rate law. And then you just look through your choices. Good.